This is the first video in Chapter 3, Section 1. And this whole chapter is about quadratics, which, just kind of an FYI, are always in the form ax squared plus bx plus c equals 0. That's considered standard form, where the a is the coefficient on the x squared term, the b is the coefficient on the x term, and the c doesn't have an x, so that's the constant in the equation. And these actually are named. The x squared term is called the quadratic term. So just some information that I feel you should know about quadratics. The bx is called the linear term, because if you have just the bx plus c part, you don't have to write this down. But if you have the bx plus c part, this looks a lot like, right? Which this is the equation for a line. And so the bx plus c looks just like mx plus b. You just have to change around letters, which are interchangeable. So that's just kind of some generic information on why that's the linear term. And then c is the constant term. Remember that your constant term doesn't have, good Lord, I'm trying to get underneath here. Hide that. Okay, so the constant term has no variable, or quite literally, it's c x to the 0, and anything raised to the 0 is 1, so it's c times 1, which is just plain c, and that's why it looks that way. So it does have an x on it, it's just raised to the 0 term. Not that we think of that way, but again, this is Algebra 3. It's pushing you in your algebra career, so there's some extra stuff I might just throw in here that I feel that is important that you should know or have heard or have seen or anything like that. All right, so what we're doing here is solving quadratics by factoring. And this will be a short little video because you already know how to factor. You're going to factor a quadratic using the X method, generally. I mean, you might see difference of squares, but you could use X method on that technically as well. And then we're going to talk about 2 other ways to solve quadratics in upcoming videos. And so here's just a statement that when solving any equation, it must be equal to 0. First, so before you can do anything else. And then it must be factored, or some other method or formula can be used to solve. And so what we're saying here, we want x equals something, right? We want however many answers to the problem we can get. And just kind of a little piece of information. The number of answers to a problem to any math problem will equal the highest exponent in that problem. So that's just kind of a side note, something for you to keep in mind. So if, for example, you see x to the second plus 5x minus 6, the highest exponent is 2, so this will have 2 answers. I forgot how to spell there for a second. If you have x to the 4th plus 3x cubed plus 2x squared plus x plus 1, the highest exponent is 4, this will have 4 answers. Okay, they won't always be real answers. They might be imaginary, but it will have 4 answers. So the degree, the highest exponent, is how many answers you will always get in a problem when you're dealing with these things. So if you have a quadratic, something raised to the second power, again, back up here, a quadratic is ax squared. You should have 2 answers to these problems most of the time. If you We won't even talk about if you don't. You will always have 2. They might be the same, but you're going to have 2. So that brings me to another topic or word that you may or may not be familiar with in math, and that is multiplicity. So we need to talk about just some basic info on quadratics. So multiplicity is the number of times an answer happens in a polynomial. Okay, and we'll come back to that at the end of this lecture. We'll talk about multiplicity. This is important, though, going forward. Okay? All right, so you guys already know how to factor. So let me just kind of remind you of a couple things. The first one is this statement I made in black here, that when solving any equation, it must be equal to 0 first. Okay, this is super important. So let's go look at another problem. Switch back to a pen, and we're gonna, oh geez, not that pen. Let's undo. We'll get a green pen. All right, so we're gonna solve this equation. X minus 1 quantity squared equals x plus 5. All right, so it has to be equal to 0. It's not. So you need to do things to make that happen. So we've got to do a couple things. We have to, or here's a quantity squared. That means we're going to FOIL this. And then we're going to move these to the other side by doing the opposite operation and make the whole thing equal to 0. Now, I'm going to FOIL this without writing it twice and foiling. If you can't do that, then in your notes, you should annotate this and write x minus 1 times x minus 1, do the foiling, show all 4 steps. I'm hoping you would be able to actually do this by now. By that's what that is when you FOIL and simplify. And then I'm just going to move these guys over. So minus x minus 5 minus x minus 5. This is going to give me x squared minus 3x minus 4 equals 0. So now I have it equal to 0. Now you're going to factor using x method. So I'm going to x method. Remember that a times c goes in the top and b goes in the bottom. Then I'm going to find 2 factors that multiply to the top and add to the bottom. And then I'm going to divide by a and divide by a and simplify if possible. You can't here. So this one becomes x minus 4. This one becomes x plus 4, or x plus 1, sorry, equals 0. And now your 2 factors are the multiplied pieces. So this is a factor and this is a factor. And you're going to set each factor equal to 0 and solve. So once factored, set each factor equal to 0 and solve. So we're going to go x minus 4 equals 0, x plus 1 equals 0, and then I'm going to add a 4, add a 4. I am not always going to show this step. I'm going to expect that you can do that. And then I'm going to subtract a 1, subtract a 1. And these are my 2 answers. So these are both answers. And each one has a multiplicity of 1. They occur only one time as an answer. So x equals 4 is an answer. Now let's be clear. We can start with the answers and rewrite them as a factor and get back to the original problem. You're going to be asked to do that in the next section. So you can take your answer, write it as a factor. How? By moving the answer to the other side, and that makes it a plus 1. And then you just FOIL this out and you get this guy. So we're going to be going backwards in the next step. in the next section. So just so you know that that's going to happen. But these are pretty straightforward. You know how to factor. You know how to set things equal to 0 and solve. So this is just kind of putting it all together and reminding you of a few things. The other thing I want to show you is what happens when you have a number out front, and then we're going to do a multiplicity one. So solve 3x cubed plus 8x squared plus 4x equals 0. Well, this one, it's not in quadratic form because your factors or your exponents don't match up, right? However, you can take a GCF out of this first and need to. Anytime you can take a GCF out, you have to. So we can take an x out as a GCF. That leaves us 3x squared plus 8x plus 4 equals 0. Now you're going to factor with x method just the part that's in parentheses. So I'm going to have a 12. Remember, that's a times c, and an 8. What multiplies to 12 but adds to 8 is 6 and 2. Divide by the a term, and we're talking this polynomial. This one's gone after you factor the GCF out. So my 3 is the a. And then don't forget to reduce these if you can. 2 over 1, that's what I'm going to use. This one doesn't reduce, so I'll use this guy. We're going to bring this x down. It's in the answer. The left-hand circle here becomes x plus 2. The right-hand one becomes 3x plus 2. And now I have 3 factors, right? Just to be very clear, the x is a factor by itself. The x plus 2 is a factor by itself. And the 3x plus 2 is a factor by itself. Remember early on also, I said that you will have the number of answers as the highest exponent in the polynomial equation. In our original one, this was 3, so we should have 3 answers. That makes a lot of sense. Now remember, you set your factors equal to 0. So this guy just gets set equal to 0. 0 can be an answer. That's allowed to happen. This guy, x plus 2 equals 0 becomes x equals negative 2. And this guy becomes x equals negative 2/3. So these can also be fractions. That's fine. If you were not doing these in varsity, varsity will check them for you, right? You hit enter. It says, hey, you got 2 of 3 right. If you were doing these longhand, AKA maybe a college class at some point in time, you should go back and check these and make sure they all actually work. I mean, 0, you can do in your head. You put 0 in for any x, you get 0. 0 equals 0, right? And then you can go through and do those. But I would highly recommend. So you have 3 answers, each with a multiplicity of 1 because they all happen one time. Okay, let's see a problem where you don't have a multiplicity of 1. So we're going to solve x squared minus 6x plus 9 equals 0. It's already set equal to 0. We're just going to do our x method here. So we have a 9 and a minus 6. Well, that becomes a negative 3 and a negative 3. We divide by 1, divide by 1. So we have x minus 3 and x minus 3 equals 0. And if we set these equal to 0, we get x equals 3 as an answer, and x equals 3 as an answer. So you could answer this and say x equals 3 with a multiplicity, or you could use just mult, of 2. And that means that x equals 3 2 times. Okay, and you can see that that is exactly what happens here. So that's what a multiplicity means. Remember, we're going to be asked to start here in the next section, move the 3 over and get to here, and then multiply and get to our equation in standard form has to be equal to 0. All right, so that ends 3.1. We'll be back for video number 9 for 3.2 in a day or two. So, toodaloo for now.